In this series of videos, we're looking at the topic of simplifying radical expressions. A radical expression is an expression that has a root sign of some sorts, and then under that root sign is some quantity. Oftentimes it's strictly numeric. Sometimes it can be algebraic, meaning it could have letters as well as numbers. In this particular instance, we're looking at roots that are indicating the square root. And remember, the square root is the idea where you're looking for the number that if we would square that number, it would produce this number. So we're looking for the square root of 18. Well, the square root of 18 is not a whole number. There is no whole number that you could square that makes 18, as there is with, say, the square root of 36. The square root of 36 is the whole number 6. In fact, that's why 36 is in the list of what we call our perfect square numbers. Perfect square numbers are numbers when you take their square root, you get a whole number answer. So the square root of 36 being 6, the whole number, puts 36 in our list of perfect squares. However, 18 and 12 are not in the list of perfect squares. If you tried to take the square root of those numbers, you would not get a whole number answer. So one technique is to get an approximation by using your calculator. Another technique is to simplify the radical expression, which leaves your answer as an exact answer, which sometimes is preferable depending upon what you're going to be doing with that answer once you have found it. So I want us to go through this process of simplifying radical expressions. What I suggest to students is that you first make a list of, either mentally or physically, a list of the perfect square numbers. And here are the beginning perfect square numbers. And again, perfect square numbers are numbers that if you take their square root, you get a whole number answer. The square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, and so on. See how the square roots of those numbers are whole number answers. We use those perfect squares to try to simplify the radical expression. And the process we use is this. We look at the radicand. That's what the quantity under the radical sign is called. We look at the radicand. Can we find one of these numbers that is a factor of that radicand? Can we find one of these perfect square numbers that's a factor of 12? And just to remind us of vocabulary, factor means it would have to divide into it and give us a whole number answer. Well, the answer is yes. 4 is a factor of 12. There's the characteristic of roots that the root of a product is equal to the product of the roots of factors. So the square root of 12 can be broken apart into the square root of 4 times the square root of 3. 4 times 3 makes 12 when we multiply. The square root of a product is equal to the product of the square roots of the factors of that product. So the square root of 12 we can break apart into the square root of 4 times the square root of 3. The square root of 4, again, is the whole number 2. So I can replace the square root of 4 with the whole number 2. And the simplified form of the radical expression square root of 12 is equal to 2 times the square root of 3. I know I'm done because 3 does not contain any of these perfect squares as a factor. I really can't go any further. In fact, almost always if you end up with a prime number here, still under the radical expression, you know you've simplified the expression completely. There would be no way that you could have a prime number here and still be able to simplify the radical expression further. Let's do the same thing here to the square root of 18. If we look at 18, we should quickly recognize that 9, one of our perfect squares, is a factor of 18. So we can break apart the square root of 18 into the square root of 9 times the square root of 2. And the square root of 9 can be replaced with 3. So the simplified radical version of the square root of 18 is 3 times the square root of 2. This process is used sometimes when we are solving right triangle problems using the theorem of Pythagoras, a squared plus b squared equals c squared. and is often used when we are solving quadratic equations using what's called the quadratic formula. So this is our process of simplifying radical expressions.